referenced with m, and we can work it out using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is when we have 2 points and what the 1s and the 2s are is simply notation. What you would do in this case is you would take one of your 2 points, whichever one they are, and you'd call those the 1. So this becomes x sub 1 and y sub 1. And your other point becomes x sub 2 and y sub 2. And what it does is it forces you to get an order correct when you're putting the values together. So, Christopher, help me out. Can you give me a point and give me any x and y? Not too, don't give me, values that are too big, but you can throw a negative in there. Negative 6 and 3? Okay. Cool. That's a good one. Somebody else want to give me another point? Yes?
5 and 8.
5 and 8. Good deal. I got it. So, when we're looking at a problem, if we want to know the slope between any 2 points, we can use this formula. To use it correctly, we have to label these bits. So let's call the negative 6 and the 3 the x sub 1 and the y sub 1, and the 5 and the 8 the x sub 2 and the y sub 2. So your first point and your second point, if you will. Okay. Now, if I put this into my slope formula, I'm going to take y2. Remember, the y's are always your last values. And I'm going to subtract. I've got a negative in the formula. I'm going to subtract 3, the y sub 1. So I'm replacing the values that I know with the variables here. And then I'm going to go 5. Now I've got to be careful. In the formula there's a negative or a minus, but I'm putting in a negative. So what happens when I minus a negative? It becomes plus, right? So remember that the negative is in there. So this is going to be 8 minus 3 is 5. And 5 minus a negative 6 is going to be 5 plus 6, which is 11. And there's my slope, 5/11ths. Now, that is the way that teachers have taught this thing forever. I've taught it for years and years and years. But the other day I showed you a slightly different method that I kind of like better. No matter what method you choose, there's always ways to get it wrong. Slope is always y's over x's. So instead of putting these variables down and all that, what we do, or what you can do, is you can say, okay, here are my y's, the 3 and the 8. How much change has to occur to go from 3 to 8? Think about a number line. How much traveling on a number line has to change to go from 3 to 8? That's plus 5, right? And for the x's, how much change has to occur to go from negative 6 to 5 on a number line? That's your 11, right? So your slope, 5/11. I kind of like this better, but I see lots of mistakes with it. I see students starting with x's first and putting that on top. Well, that's going to write your slope upside down. Or going x to y and x to y, or y to x. You can't do that. You have to make sure you're going y to y and x to x if you do this method. But I like this one. I think it's easier to do in your head, and you don't really have the minusing and negative so much going on. Okay, So the next formula is the point slope. Point slope formula. And we use this when we know a point on a line and a slope. I mean, it's sort of called point slope for a reason. If you know a point and the slope, you can write the equation of the line. It can, any point. It doesn't have to be that starting point on the y-intercept, although that makes life easy. So let's look at this. This formula is y equals m. What's m? Slope, good. Times x. Y and x are variables. And then it's going to be x minus x1 plus y1. Where x and y are variables, they stay x and y. x1 and y1, these are a known point, the values of a known point. And of course, m is the slope. So x and y stay x and y. x1 and y1, those are some values that we know. Let's take what we have. Let's see how we did at making a line. I'm wondering if our y-intercept is going to be funky. It may be. So we know a slope from these 2 points. Now let's pick one of these 2 points. We only need one point and the slope to get the equation of the line. So if you have 2 points to choose from, then we need, sorry, that was unintended. Okay? Come on, wake up, head up. I'm giving you notes and you're not writing anything down. That's not cool. What do you mean you don't have a pencil?
I left all my stuff in my other binder.
When you come into class, you say, "Hey, Mr. T, I left my stuff in the other binder. Can I borrow a pencil or something?" All right, that's how it works. Okay, so you don't get squirted. Okay, so you pick one of the 2 points. If you have 2 points, you pick one. Which one's friendliest, you think? The -6,3 or the 5,8? You like the 5,8? Let's use the 5,8. So, given m equals 5/11, and I've got a point, 5,8, we do have to recognize that this is our x sub 1 and our y sub 1. Okay. Now, I'm going to put these into the formula. Y equals, my first variable, equals m, 5/11. Yeah, this is going to be kind of ugly, I think. Times x, a variable, minus 5. And then we just add or subtract, if the sign tells us to, the y1. Okay. That's it. That's it. That's now in point slope form. You've got a point, you've got a slope. What might we do with that, though? what we would do with this is we would simplify it by distributing. But I think in this case we're going to have some pretty gnarly numbers. So let's talk about the next step. So what is the next step? The next step is slope-intercept. This is what you want, the slope-intercept formula. This is what we want. This is a slope and y-intercept are known. Y equals mx plus b. You guys have seen that before. Certainly in here a little bit, but I think you've seen it in previous years. What's great about slope-intercept form is it's easy. It's easy to graph and it's easy to assess. And come on, who doesn't want to make math as easy as possible, right? So if I tell you m equals 2 and b equals 7, and I ask you to write an equation of the line, by the way, it's not very often going to be this easy, but we did have some problems like this the other day, we would say y equals 2x plus 7. What's the most likely thing that you'll forget about this? Putting in the x, right? The slope multiplies x every time. Okay? Don't forget the x. So what if I had a problem? I'm going to change it. I'm going to say m equals 1/2, and I give you a point that's, say, 10 and 4. And I want you to put this into slope-intercept form. What you would have to start with is point slope, because that's what you have. So you'd have to go back to that other formula, point slope. By the way, this, the slope formula, you need to memorize that. That can't be something you go looking for every time. Yes? Well, they're different in the sense that slope, you have to do any of this, if you have 2 points, you would have to start with slope, right? You have to get the slope first. Then you can go to point slope, because you'd have a point and a slope. You pick the point. And then the last thing is what we're going to do next, is how do we get from here to here, right? So let's plug this in. So if 10 is my x1, I'm going to put it here. This is my x1 and my y1. Now what I would do is I would distribute. Now with any luck, if this is a fraction, it'll simplify nicely. That's kind of why I changed the last one. It wasn't going to simplify nicely. For notes, we want some simple stuff. So I'm going to distribute this. So y equals 1/2 x. That's easy enough. And what's half of -10? -5. And then I add the 4. And what makes this easy is the graphing. Assuming we're counting by ones, we'll start at b by -1. from there, I've got rise over run, the slope. So that's going to be up 1 and over 2, and there's the line.